Our project is automatic car parking system. Nowadays, as the number of vehicles increases, parking problems also increases. Automatic car parking system aims to offer convenience for vehicles users and efficient usage of space for urban-based companies. In this project, it is aimed to use PLC, which is widely used in the industry as a controller. The main purpose of this project is to make parking easy for drivers and also for the operator who is handling the parking area. In addition, it is planned to minimize the number of accidents and complexity and maximize time savings. This project includes the study of PLC sensors, HMI motors, etc., instruments which are members of the industrial automation family. In this project, we made a representation of a multi-story park system that uses the input model from IR sensors and LDRs to provide it to the PLC to ensure easy, reliable, and effective car parking management.
Hello, I'm Beyza. I'm talking about technical requirements. In our project, for checking if there is any space available for parking or not, there will be a green light and red light. There will be a rail system for horizontal movement, a pulley system for vertical movement. The limit switch uses physical contact to detect the presence of an object. Here we use the limit switch in order to control the rotation of the platform. Relay are simple switches which are operated both electrically and mechanically. Relays are used for controlling the various motors used in the model when the PLC gives the signal to relay on the basis of what information is received from the sensors. Relays operate and start or stop different operations. DC motors is the electromechanical energy converter which works from a DC source and generates mechanical power. We use DC motor in order to perform various horizontal, vertical, and rotatory motions in our project.
Hello, I am Buse. I'm talking about servomotor. It's a rotary or linear actuator. We will use servomotors to perform both rotational and linear precise position control. Step motor is brushless DC motor. We use it to move the door up and down to the car. PLC is inertial digital computer and it is advantages. User can fix or change the program in the runtime. We can control the things remotely with the integration of SCADA, and response time of PLC is very less. Converters, we will use those converters to convert digital to analog signal or vice versa. Switching mode power supply, we will use it to convert the AC voltage that comes from the power supply to DC voltage. An emergency button, we will use it to interrupt the full process in emergency situation, and computer, we will use it in order to program to PLC and to perform human machine interface.
Hello, it's me, Yusuf Islam Tuncer. I'm gonna talk about the system architecture of the project. On the left-hand side, there's an AC power supply which converts the AC voltage to DC voltage. SMPS block are connected to PLC, HMI, and sensors. Also, HMI module is controlled by a computer. Or sensors fill some quantities and send signals. ADC module convert these signals from analog to digital and convey PLC. On the other hand, there are many output units like step servo and DC motors or lamp. These outputs are driven by motor drivers. Finally, limit switch and emergency button are located on the right hand side. These parts works with interrupt logic. Thank you for listening.
Hi teacher, I am Cenk Safa. I will talk about software function. Our project is two-story car park system. We made our software function block by block. First block has a start-stop button. We start and shut down the system, and we have two HMI button and two physical button because HMI button cannot connect directly to the PLC. Second block has barrier gate. We will control the barrier. The barrier system will be activated at the time of car enters and exits. We have timer and function in this block. Third block. We use is block to record the number of inside. We have 12 cars. We send data to the second block according to vehicle status. We will use the place of the vehicle in other block.
Hi, I'm Melih. In this block, we will gather the data about total number of cars for the entrance of new car. In this block, we will benefit from timers that calculate the total time to price it. These blocks will do all parking process with controlling the motors based on proximity data, and also it will make calculations that enable us to control system according to data such as car position, In here, I would like to talk about the algorithm. If we choose parking and if the car is suitable to pass, a green light will be on and all the parking process will be done. If we choose retrieve, all the retrieve process will be done, and interrupt will be activated if press emergency button or limit switch is on. Thank you.
Hello, my name is Hasan Besri Arzoğlu. I'm gonna talk about the input and output modules. First component is power supply. Many sensors used in the system work with 12 volt, 5 volt or 3.3 volt. Therefore, a voltage reducing circuit element is needed. Second component is buzzer. The main purpose of the buzzer is to warn the drivers and direct them. Third component is buzzer driver. Buzzer works with 12 volt. A circuit must be set up to operate this system. In this context, it's planned to use transistor. Last component is LDR sensors. It's planned to precisely calculate the presence and position of the vehicle with LDR sensor placed on the ground. Last component is proximity sensor. The main purpose of this sensor is to detect the vehicle.
Hello, I am Ufuk. Now I will be talk about the I/O variables and software HMI part of the project. These pictures are just for demonstration. The first picture is the main screen, which have buttons, and the second picture is the first floor, and the third picture is the second floor. And this is the list for digital input in our HMI. As you can see, these are all buttons on the HMI. And these are analog input variables for HMI. Most of them and all of them are sensors. And these are the digital output variables for HMI. The first three is for the physical components and the others for the HMI indicators. And these are the motors we will use, which are also analog output variables for our HMI. Thanks for listening. If you have any questions, please don't hesitate to ask.